All right, good evening, everybody. It's time for our next lesson. As promised, I will try to keep this one short because this one is nothing more than what we are talking about as powers of powers. Yes, powers of powers. Kind of like Superman can leap over a single building. No, I'm kidding on that one. No, what this really talks about, and let's look at a kind of an example here. If I had x to the fourth to the third power, so you can see we have a power raised to an exponent, or a powers, because that's a whole big power of a power. But think about what this really means. This is x to the fourth. And think of x to the fourth as the base to the third power. So what does that mean then to us? What that means is nothing more than x to the fourth times x to the fourth times x to the fourth. Well, we know from last lecture that x to the fourth times x to the fourth times x to the fourth, we're multiplying three powers that all have the same base. So we're just going to be adding the exponents. So that would be x to the 4 plus 4 plus 4, which we obviously know is 12. Okay, are you seeing it yet? I hope so. Because what you probably noticed was that, 4 times 3, that's just 12. And that's exactly what it is. Let's talk about the general rule then. The rule says if I have a power and I raise it to an exponent, then all I have to do is multiply those exponents together. So a to the m to the nth is a to the m times n. Okay, let's have you try a few of these real quickly. 4 to the 7th to the third power, x to the 5th to the 9th power, a to the 13th to the 0 power. Pause the recording. Let's see how you do. Okay, let's see what you got. Let's see if you got it right. 4 to the 7th to the third power. Well, if you did it right, you did 4 to the 7 times, not 7, but let's undo that. It's not going to undo. Erase that. Times 3, which is 4 to the 21st power. This one, we have x to the 5th times 9, which will give me x to the 45th. And of course this, did I catch you? It's to the 0 power. We don't even have to multiply anything. It's just going to be 1, seeing if you were paying attention that time. The final rule that we have to kind of talk about is what happens when we have this. A to the m, b to the n, to the p power. What happens when you have a monomial that has multiple variables in it, all raised to a power? Well, nothing different. All we're going to do is we're going to take and we're going to multiply the outer exponent to all of the inner exponents. So a to the m, b to the n, to the p power is just a to the mp, b to the np. Here, look at this example. X squared y cubed to the 4th power. Well, that's nothing more than x squared times 4, y cubed times 4, or x to the 8th, y to the 12th. But be careful, because sometimes I might throw this at you. X, y to the 5th, to the 3rd power. And you're thinking, okay, so I'm going to multiply the outer exponents to the inner exponents. So I'll multiply the 3 and the 5 together, right? No, you would have forgotten something. See, everything has an exponent, even if you can't see it. For example, the x has an exponent of 1. So this is really x to the 1 times 3, y to to the 5 times 3, or x to the third, y to the 15th. Now, one last thing I want you to be aware of, and that's if I do this. 2x cubed to the 4th power. Now, when we do this, I want you to be careful. We are multiplying the outer exponents to all the inner exponents. Also want you to remember something I told you at the very beginning. Remember, powers are powers, numbers are numbers, and we treat them differently? See, here, don't you dare multiply that 4 to that 2. Because what's the exponent on that 2? That's right, it's a 1. So I get 2 to the 1 times 4, x to the 3 times 4. So what I really get is 2 to the 4th, x to the 12th. And that is the end of this lesson. I will see you tomorrow where we'll take a look at it.